Okay, we're starting with 9.1. Today's date is April 25th. I know this because my wife's birthday is in 2 days. No, my wife's birthday is tomorrow. It's 26th, isn't it? Say the 26th? Yeah, my wife's birthday's. And she turns a special number that I will not mention, kind of like Voldemort. You're not supposed to say that number once women turn that number. But we start at question 5, which is 10 times less than my wife's age. And it says, write an inequality sign that best matches each term. So at least means, if we think about at least, it must be less than, or sorry, greater than or equal to. Greater than or equal to. So the at least sign looks like that. Fewer than is just less than. Maximum means you can't go past it. So uh, must be less than or equal to, because that would be the maximum it can be. Anything else underneath that is fine. And must exceed, all numbers must be greater than. So those are your 4 symbols for question 5. For question 6, which inequalities is 4 a possible value? So all numbers greater than 3, is 4 one of those numbers? Yes, it is. 4 can be a number greater than 3. All numbers less than 4, can 4 be a value? No, it can't. All numbers greater than -9, would 4 be a number that's greater than -9? Yes, it is. And all numbers greater than or equal to 4, is 4 one of those numbers? Yes, it is. Question 7, write a word statement to express the meaning of each inequality and give 3 possible values. So question A would be all values greater than or equal to 8. And 3 possible values for any value that's greater than or equal to 8. I'll make a set of numbers with these brackets that you've probably never used before, but they're beautiful. They're a mathematical set of values. Any number that's greater than or equal to 8, well, 8's one of those numbers. 8.3 is one of those numbers. And 9 and 1/3. Why did I choose those numbers? I have no idea. But those are 3 of my examples that are possible values for y. The next one would be all values less than -12. Values that might include any value less than -12 would be -12.1, -13, and -1 million, just because I can. Question C, all values less than or equal to 6.4. And some values that might include all values less than or equal to 6.4. Well, 6.4 is one of those values that is less than or equal to. And we can go less than would be 6.3 or 0. Those are the ones I chose. Those are all values that are less than or equal to 6.4. And finally, the last one, all values greater than -12.7. All values greater than -12.7. Values that might include would be -12.6, which is greater, -11, which is greater, and 0, which is greater than -12.7. Question 8, at the spring ice fishing derby, only fish 32 centimeters or longer qualifies for the prize categories. Draw a number line to represent the situation. Um, I'm going to draw a inequality first. So the size of the fish must be greater than or equal to 32. That's really what I'm trying to draw with a number line. So therefore, if I put 32 in the middle and 33 centimeters here and 31 here, a closed boundary point, because you can have a fish that's 32 to qualify, and any size longer would be acceptable. Write a statement to represent the sizes of fish that qualify for prizes. I guess that would be this statement right here. It's it. You wanted me to write an algebraic statement. Question 9, write a word statement. Oh, so many words in writing. To represent each inequality. Because it's a open boundary point, it does not include it. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all numbers greater than all numbers greater than 10 if I wanted to do it algebraically. Since it's a closed boundary point, it includes it. So we're going to say all numbers less than less than or equal to, we don't judge, all numbers less than or equal to -2, or all numbers less than or equal to -2 is the algebraic way of representing them. And finally, the last one, all numbers greater than, or as Gavin would say, more than, or equal to -12, or all numbers greater than or equal to -12. And I know this symbol belongs there because we're using a closed boundary point. And that's your answer to question 9. Yeah, no, I made a mistake. It's supposed to be -13. Did I make another mistake too? What's the first one? Oh, yes, I did. Why don't the people stop me when I make mistakes like this? 1, 2, 3, 4. The greater than 4, right? Huh, 4 it's supposed to be. You make me look so silly on YouTube, and now all of my fans in the Philippines who watch this video are going to think I'm an idiot. So humbling. Now we have to express it algebraically, not in words. So we have 12.7 here, correct? So all numbers less than but not equal to 12.7. I know that I don't use the equal sign because it's an open boundary point. All numbers, this is a great one, greater than 4.6, 4.61, 4.62, 4.69. This would be 8765, 4.65. Is that right? All numbers greater than 4.65 is your solution for that one. And finally, your last one, all numbers less than or equal to, because it's a closed boundary point, -24.3 is your answer for that one. This question 10, almost with 100% certainty, will appear on your summative test. Love this question. Question 11 says sketch a number line. We got 6 minutes. We can do this. X is greater than 3. Put 3 in the middle, 4 over here, and 5 over here. X, or all numbers greater than 3, does not include it, so it's an open boundary. Should use red. It's prettier. All numbers greater than 3, but it's an open boundary. Make sure it's an open boundary. Seriously, everyone's going to think I'm a complete banana head. They're going to be like, this guy is intoxicated making a math video, 2 and 4. Oh, and I even made, yeah, that's fine. That's fine. So -19 goes here. Don't make a mistake. -20 goes here. -18 goes here. All numbers greater than or equal to -19. It's a closed boundary point because it can be that, and greater than would go this way on a negative number line. That's C. Question B, all numbers less than 12. Put 12 in the middle, 11 over here, and 13 over here. All numbers less than does not include 12, so open boundary. All numbers less than -12. And finally, I'm going to read it backwards. All numbers less than or equal to -3. Right? Don't read -3 is greater than or equal to X. It'll blow your minds if you try and think about that. So all numbers less than or equal to -3, -3, -4, -2. All numbers less than or equal to is a closed boundary point, and our arrow goes that way.